So exercise 185, page 466, question number 9. Integrate this wave function, 3 sine to the 4 theta cos theta between 0 and pi by 2. So if we look at the wave, we can see the wave function is plotted out here. Half a cycle lies at pi by 2. So if we look at this point here on the wave, pi by 2, then you can see that's why we're taking the limit of pi by 2. So we're actually finding the area under the curve between these 2 points here. We could, if we look at the wave function just for a second, we can see that cos theta, when theta is pi over 2, the cos of 90 is 0, so it actually doesn't matter what 3 sine to the 4 theta is. When theta equals pi over 2, then y equals 0, which is this point here. And so that's actually helping us to determine what the limit is. So let's have a go at the integral then. So all we do now is use the integration by algebraic substitution, letting u equal sine theta. So then when we differentiate, we get cos theta, and hopefully that should cancel out the cos theta term in the wave function. So that's the way to proceed with it. And then when we've done the integral, just put the limits in, making sure our calculator is in radians. So if you'd like to have another go at it, the solution will follow. Oh, and there is an extension question that follows this for you to have a go at if you need to look at the full solution. So let u equal sine theta. So therefore du by d theta equals cos theta, and d theta equals du over cos theta. So we can put this information into the original integral, and we get the integral of 3 u to the 4, because we've let u equal sine theta, times cos theta du over cos theta. So that means, as required, the cosine theta, the theta variable, disappears, and we're left with just 3u to the 4 du. So this becomes 3 times the integral of u to the 4 du, which equals 3 times u to the 5 over 5 plus c. Replacing u with what we let u be, which was sine theta, we get the integral 3/5 sine theta to the power 5. But of course we're putting this into limits, so this equals 3/5 sine to the 5 theta between the limits of 0 and pi by 2. So this means we get 3/5 of sine to the 5 of pi over 2 minus sine to the 5 of 0. Well, sine of 0 is 0, so sine to the power 5 of 0 is still 0. So that term's disappeared. And then we put our value in, sine to the 5 of 5 over 2. And we should be able to work out the solution in the text. And so obviously we're looking at this, sine to the pi, sine of pi over 2, sine of 90 degrees is just 1, so sine to the power 5 of 1 is still 1, so we end up with the solution 3/5, which is 0.6. Have a go at this question now. Integrate between 0 and pi over 3 this wave function 2 cos squared 3t sine 3t. If we look at this, if the sine of 3t is 0, the whole thing is going to be 0. So this term here, the sine of 3t, is going to determine my limits in a way. When 3t equals 0, then that gives us our limit. So it will equal 0 at 0 and also at pi. So when 3t equals pi, y equals 0. So that means t equals pi over 3. And that gives us this limit here, the pi over 3 term. So it comes to 0 at pi over 3. So that gives us our limits of 0 and pi over 3. As a little extension question, you might want to consider why it is that it also drops to 0 at this point here. Anyway, have a go at the extension question and see if you can work out what the value of the wave of this wave function is between 0 and pi by 3, which is the area underneath here. Have a go at it, and then the solution is at the end. So if you've had a go at this one, what I would do is let u equal cos 3t, and then put in du by dt equals minus 3 sine 3t, and then carrying on, you can see the solution below here. And you end up with a value of 0.6 recurring, or 2/3. You could, if you wanted to, have a go at working out this extension question and the previous question using the idea of changing the limits to in terms of u, and see if you get the same answer.